Welcome to the Blue Collar Tutor Test Preparation Series for the New York City Fire Department, S-13 Certificate of Fitness for Citywide Supervision of Standpipe Systems, and the S-14 Certificate of Fitness for Citywide Supervision of Multi-Zone Standpipe Systems. It is critical that you understand this material to pass the exam. If you haven't already, it is recommended that you watch the brief overview video at the beginning of this series before moving on to the subsequent volumes. After an initial run-through of the entire series, refer back to each of these volumes, as often as needed, until you are confident with the material covered in each section. Once you become proficient with all of the material in this course, continue on to the S-13 and S-14 practice test sections to test your knowledge of the material. Chapter 9. Water Supply. Standpipe systems may be supplied from one or a combination of sources. For example, they may be supplied by public mains, gravity tanks, pressure tanks, reservoirs, rivers, or lakes. A single water supply would appear to be all that is needed to supply a standpipe fire protection system. This assumes that there is enough water at an acceptable pressure. However, there are a few reasons why it is good to have a second water supply source. These reasons include, but are not limited to: 1. A single supply source may be out of service due to maintenance or repair during a fire emergency. 2. A single supply source may be disabled during a fire or before the fire is fully extinguished. 3. The water supply source may fall below normal pressure or volume during an emergency. 1. Pressure tanks. Pressure tanks are enclosed water tanks of limited size. Air pressure in the tank permits forceful discharge of water from the tank into the standpipe system. A pressure tank may be used as a primary or secondary water supply for a standpipe system. A pressure tank is usually housed in an enclosed structure. The temperature in the enclosure is kept at 40 degrees Fahrenheit or above. The heated structure may be located anywhere in the building or even outside the building. Pressure tanks shall be maintained 2/3 full of water and 1/3 full of pressurized air. The acceptable air pressure inside the tank may vary from 15 psi to 80 psi, as per the Department of Buildings rules and regulations. The air compressor shall be provided with automatic controls for maintaining the air pressure. The capacity of the compressor shall be sufficient to build up the tank pressure to 75 psi within 3 hours or less. Pressure tanks shall be provided with approved closed-circuit high and low water alarms. Pressure tanks shall be located at or above the top level of sprinklers. The air pressure in the tank is automatically maintained by an air compressor. The maximum capacity of pressure tanks is typically 9,000 gallons. Some standpipe systems require more than 9,000 gallons of water. If necessary, several pressure tanks can be used in combination to supply the system. Pressure tank alarms. All pressure tanks used to provide the required primary water supply of a standpipe system should be equipped with 2 high and low alarm systems. One system monitors the high and low air pressure. The other system monitors the high and low water levels. The alarm system automatically monitors the air-to-water ratio, which should always be 1/3 air to 2/3 water. A high-low alarm or supervisory signal will enunciate when the water level or the air pressure falls too low. When this happens, the pressure tank shall be adjusted or repaired immediately. Supervision of the pressure tank. The pressure tank may also be supervised by an approved central station company, which monitors the standpipe system. Supervisory devices alert the central station company when there is a problem with the tank's water level, air pressure, or water temperature. These devices also alert the central station company when water has been discharged from the tank. When water has been discharged through a hose outlet or a sprinkler head, the fire department borough dispatcher shall be notified. The central station company notifies the building owner when an alarm or supervisory signal is transmitted. It is required that the pressure tank is returned to good working order immediately. The water gauge valve must be opened to examine the water level. When the valve is opened, the water will flow into the gauge. This allows the certificate of fitness holder to compare the water level in the tank to the desired water level mark. Adjustments to the water level shall be made as needed by an authorized individual. After visually inspecting the water gauge valve, the valve shall be closed. When the valve is closed, the water and air in the tank are isolated from the sight glass. If the gauge glass breaks the volume of water and the air pressure are not affected, The inside of pressure tank shall be inspected every 3 years. The inside of the tank shall be maintained free of rust and foreign materials. The temperature inside the structure that houses the pressure tank shall be maintained during cold weather to ensure that the temperature is at a minimum of 40 degrees Fahrenheit at all times. 2. Gravity tanks. The gravity tank supplies water using the force of gravity. Gravity tanks are used for water storage. They are made of wood, steel, concrete, or other approved material. Gravity tanks are used as a primary or secondary water supply source for standpipe systems. A gravity tank delivers water to the standpipe system without the use of pumping equipment. A gravity tank shall be at least 25 feet above the highest standpipe hose outlet that it supplies. Tanks may be located on the tops of buildings or raised on tall supporting towers. A gravity-feed standpipe system distributes water throughout the fire protection piping without the use of pumping equipment. The water pressure in a gravity tank system depends on the elevation of the tank. This is a major advantage over other kinds of systems. For every 1 foot the tank is above the discharge outlet, an additional 0.433 psi of water pressure is achieved. For example, a tank elevated at 100 feet above the discharge outlet will produce a pressure of 43.3 psi. Automatic fill pumps supply the water to most gravity tanks. The pumps shall fill the tank at a rate of a minimum of 65 gallons per minute. 2 floats control the amount of water in the tank. The floats turn on the fill pump when the water in the tank is too low. The floats shut off the pump when the desired water level is reached. The floats make sure the gravity tank always has the right amount of water to supply the standpipe system. All gravity tanks have an overflow pipe that drains off too much water in the tank. This happens if the floats do not turn off the fill pump. A fill pump is not necessary if the water pressure in the city water main is able to keep the tank filled with the right amount of water. Gravity tanks are exposed to very low temperatures. All parts of the gravity tank must be insulated or heated to keep the water from freezing. Several methods are used to heat the tank and the pipe that supplies the water. 1. Hot water is circulated by gravity. 2. Steam is discharged directly into the tank. 3. Steam coils are placed inside the tank. 4. Heat from the sun is used. The certificate of fitness holder can find out the temperature of the water by using a thermometer. The thermometer is located near the heating device. Severe damage can occur to the piping and the tank if the water inside the tank freezes. During freezing weather, the temperature of the water inside the tank and the riser must be checked daily or weekly. The temperature of the water shall always be at least 40 degrees Fahrenheit. Ice should not be allowed to build up on the gravity tank. The extra weight of the ice might weaken the supports of the tank and cause the tank to collapse. Falling icicles may also cause damage or injury. It is essential to be sure that the tank is properly heated, insulated, and carefully maintained. The gravity tank shall always have a full supply of water. A full tank of water is needed to be sure the standpipe system works properly during a fire. Keeping the tank full of water also prevents wooden tanks from shrinking. A full tank of water also helps to keep steel tanks from rusting. It is best if gravity tanks are used only for fire protection and for no other purpose. Tanks used for other purposes need to be refilled more often. The tanks become settling basins for sediment mixed in with the water. This sediment is then drawn into the piping. This may cause the standpipe system to become clogged and not work properly. The borough dispatcher should always be notified when a tank cannot be used for any reason. Failure of a standpipe system supplied by a gravity tank during a fire is usually caused by not enough water in the tank. The standpipe system cannot be supplied if there is not enough water in the tank. Too much water in the tank can also cause the fire protection system to fail. Too much water in the tank may cause damage due to the weight of the extra water. This could cause the gravity tank to collapse. Gravity tank supervision. The gravity tank must be constantly monitored to be sure that the tank and its parts are working. Electrical supervision devices monitor the water temperature and the water level in the gravity tank. These devices send signals to a central station company about the water level and water temperature. The central station company notifies the certificate of fitness holder when a problem with the gravity tank is detected. The certificate of fitness holder should correct the problem as soon as possible. The supervisory devices are sometimes called high and low alarms, since they also send audible signals to alert the certificate of fitness holder when there is a problem. Combination gravity tank and pressure tank installation. Pressure tanks may be used in combination with gravity tanks to supply a standpipe system. Both tanks may be used to make sure that an adequate water supply is available. The pressure tanks also provide added water pressure to the fire protection system. 3. Fire pumps. A fire pump can be used as a primary water supply source for a standpipe system. The fire pump draws water from a suction or gravity tank and pumps it into the system when needed. Other sources of water supply for a multi-zone standpipe system can be fed with gravity and/or pressure tanks to supply the system. A fire pump is usually connected to a public water main, which may be considered to be one of the most reliable water supply arrangements. Fire pumps are designed to take the water from a supply source and then discharge the water into the standpipe system under pressure. The pressure with which the water is discharged from the pump is called the total head. The total head is usually measured in psi. The higher the psi rating of the pump, the greater the pressure with which the water can be discharged. The centrifugal pump. The centrifugal fire pump is the standard pump currently used in fire protection systems. This is the preferred pump because it is reliable, compact, requires low maintenance, and it can be powered by a variety of drivers including electric motors, diesel engines, and steam turbines. Centrifugal pump impeller. The water available to the centrifugal pump shall always be under pressure, since the fire pump cannot draw water by itself from the supply source. While most pumps are supplied by municipal water mains, suction tanks may also be used for pump supplies. These tanks must be able to provide sufficient pressure to the pump for normal operation. The water flows from the tank through the supply inlet into the pump. As the water flows to the center of the pump, it passes a rotating impeller. The impeller flows the water through the inlet side of the pump. The impeller discharges the water under increased pressure through the standpipe system. The centrifugal fire pump is cooled and lubricated, while in operation, by water supplying the pump. Centrifugal fire pumps are rated between 25 gallons per minute up to 5,000 gallons per minute. Most centrifugal pumps have a single impeller and are therefore commonly single-stage fire pumps. 4. The vertical turbine pump. The vertical turbine pump is designed as a modified centrifugal pump that can draw water from streams, ponds, and wells. Unlike the standardized centrifugal pump, the vertical turbine pump does not require the suction supply to be under pressure for it to operate. Instead, it draws the water into the pump through suction. When it reaches a rotating impeller, the water pressure is then increased and is forcefully discharged through the fire protection system. Although the vertical turbine pump is capable of drawing water from a well, it is generally not recommended to use a well as the main water supply source because it may dry up without warning. Should the well dry up, it would make the fire pump useless. It is better to draw from the well and to fill a water storage tank. The fire pump should then be attached to the storage tank, as it is a more reliable supply source. It is important to inspect the water intake hose, foot valve, and the strainer regularly. Mud, gravel, leaves, and any other materials can obstruct a system's piping and cause damage to the pump. Pump activation. A fire pump can be started automatically or manually. The pump can be started automatically by an electric controller or an engine controller. Controllers activate the pump when there is a drop in water pressure or water flow within the fire protection system. Sometimes remote push buttons are used to activate the pump. These remote push buttons are designed to start the pump, but not to stop the fire pump. Many fire pump controllers are manufactured with maximum run timers that automatically turn the fire pump off if an upper pressure limit has been reached. As per the fire department commissioner, these timers must be disabled for all automatic fire pumps in New York City. 5. Pressure maintenance pumps/jockey pumps. Jockey pumps are designed to automatically or manually operate when there is a slight drop in pressure due to the leakage within the system or a pressure surge. The jockey pump restores the pressure in the fire protection system to the required level. When the drop of pressure within the system is greater than the capacity of the jockey pump, the fire pump is activated. Because this pump is considered a convenience pump and does not supply flow or pressure during the event of a fire, it does not require inspection, testing, or maintenance as per the National Fire Protection Association 25 or the New York City Fire Code 6. Fire pump location. The fire pump should be housed in a room that is fire-resistant or constructed of non-combustible material. The pump room should be located as close as possible to the fire protection system. The pump room should be kept clean and accessible at all times. The fire pump, driver, and controller should be protected against any possible interruption of service. The temperature inside the pump room should be maintained above 40 degrees Fahrenheit at all times to prevent freezing of the water. The pump room should only be used for fire protection functions and not for general plant operations. No storage is permitted in this room. 7. Operation and supervision. When fire pumps are activated by electric automatic controllers, it is essential that they are constantly monitored to ensure the availability of the electrical power supply in case of an emergency. For this reason, supervisory devices are installed on the pumps to alert the certificate of fitness holder and/or a central station company when there is an electrical power failure. In cases where steam turbines or internal combustion engines are used, similar supervisory devices are installed to signal when there is a problem with the controlling equipment. This concludes Volume 5. Repeat each chapter as often as needed until you are confident with all of the material. A transcript of this material is provided for free by the New York City Fire Department. See the link in the description below to upload the transcript and additional reference guides that you'll need to familiarize yourself with in preparation for the exam. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you found this video helpful, please consider leaving a like. Thank you for watching.